Hi. Alright, Maths with Kuma. You can call me Mrs. K. Alright. Now, I just want to introduce you a little bit more about myself. I call myself as Mrs. K, and actually I'm Mrs. Kuma. And I've got this side of me, I said, hey, Mrs. Kuma. But I've got two sides of me, a small K and a big K. And when exams are nearing, my K will become bigger. That's the cruelty in me. Cruel to be kind. And this K is the small K, the kindness in me. But of course, sometimes when I know you need a lot of motivation, then the K at the back becomes really big and this K becomes small. Right? So you can see, that's my signature. Alright, Mrs. K. Now let's get back to today. We're going to learn on trigonometry, the fundamentals, all right? And we're going to get a little bit more advanced. And all these fundamentals will make your trigonometry so much easier. And once you look at a sum, you can diagnose it so fast and so accurately, and you can give the right treatment. That's when you become like a maths doctor, all right? All right, before we start lessons, are you charged? Are you feeling comfortable? If you are, please loosen up and just be ready. It's something not really difficult. We're going to learn on sine rule, cosine rule, and its applications. And that these rules, these principles, these applications will help you a lot in solving lots of the trigonometry sums. Now, if you look at this triangle, a triangle has three sides, right? I call it triangle ABC. And to face the triangle A, we call it side A. To face B, this is the face B. To face C, I call it C. But you got to know there is a relationship between the angle and the side. Like for example, if I have a triangle like this, you can see that this angle is really small. The smaller the angle, the smaller the side. If this angle is big, so it faces the bigger side. Are you all clear? Alright, now you can see, if I increase the angle, I say, ooh, this angle grew, and you see the side growing. So there is a relationship, and when you do your sum, and if you see if this angle is 120 degrees and you get 10 here, and this angle is maybe 20 degrees, and you get a side 12, for example, then you tell yourself something cuckoo took place. All right? Because when 120 degrees is facing 10, how can 20 degrees face 12? It may be 2, it may be 3, it may be much smaller. Alright? So this is just an intellectual guessing of seeing the level of accuracy of your answer. Alright, have your calculators with you because we're going to apply this. Okay? Now when we have a triangle ABC, now sine A over A is equal to sine B over B equal to sine C over C. Now, whenever you draw any triangle, you will see that this amazing relationship holds. All right? You will be surprised, and I will show you because I don't want to bullshit. I want you to be convinced by what you're doing. There is this ratio that is discovered. All right? And this beautiful ratio stands for all triangles. So sine A over A, sine B over B, sine C over C. But the very important thing about here is that what side over what angle. Now, if it's the opposite side, B, you don't put it over C, you put B, angle B, sine B over B. This side. Sine A over which side? That side. Sine C over which side? The side you're looking at. Who you look at, I'm looking there. So this is called the angle. Now the other important thing is that when you use sine rule, you must have a given pair. Alright? If any one given pair is given, And then if any of these is given, you could solve it. I'll show you more as I go along. Now, this sign rule could be expressed as A over sine A, B over sine B, C over sine C. Isn't it very simple? Alright, it's either angles over the sides or the sides over the angles. Right? Really simple. Now let's look at this. Hey, now we've got a given pair, right? And you look at 56 degrees. Just ask yourself, will it be bigger than 7 or less than 7? Yes, I hear your inner voice. It must be more than 7. Alright? And if you know these two angles, can you find out theta? This is 106. Angle sum of triangle will tell you that theta is going to be 180 minus 50 minus 56. That's 106. So if you take away, you get 74 degrees. So of course, y is going to be the longest side of this triangle. Now, from there, we're going to we're going to erase this Kumar off, and we're going to apply the formula to solve for x and y. How do you go about that? Let's put in the formula. We've got it. We said A is sine 50 over 7, alright, is equal to sine 56 over x. Now the amazing rule here is that we know we can cross multiply, and so you can bring your x up, you get an x sine 50, and you can bring your 7 up, you get a 7 sine 56. Now all you need is x, hey, and this is an attachment times. Bring it over and you would get that lovely answer. Right? So can we try it please on your calculator? 7 times sine 56 degrees, answer, and you divide it by sine 50 degrees. Alright? And you get, what you get is you get 7.5756. Now in your school, they may want your accuracy to 3 significant figures, or maybe 2 decimal places, or the nearest angle, or whatever they will specify. So just listen to instructions. With me, I shall be happy if I have to 2 decimal places. So we get 7 x will be 7.58 cm. So did I tell you? It's going to be bigger than 7, right? Because this angle is smaller than 56 degrees. Now we gotta find out what is y. Can you guess, my dear? So we found theta to be 74 degrees. It's going to be bigger, right? Because it's the biggest angle of the triangle. Now we're gonna say A. But I told you that there are 2 ways of using this formula. I used this earlier on. Alright, I used angle over the side. Now I'm going to try this way. Y over sine 74 degrees. And if I put side over the angle, this should be side over the angle. Please take note. And let me take what's given here. It is 7 over sine 50. Alright, so you see it. All we need to do is bring your sine 74 here, and you've got your y, 7 sine 74 over sine 50 degrees. Can you please help me there? Yep, be a kind soul, get me the answer, and let's see what you get. Sine 74, alright, answer, divided by sine 50. Alright, you will get this answer, you get 8.78. Ooh, so your y is 8.78 78 cm. Saw that? This is the biggest side of the triangle. Now, I'm sure sometimes when you do it, you can feel that internally, yes, I'm right, because it's a bigger side and it justifies it. Okay? Now, but you want to find out, is sine rule only used for triangles that are, for all triangles? Is it for isosceles? Is it for equilateral? Is it for a scalene? Or any triangle? Alright, I would like to assure you, yes, it's used for any triangle. It need not be a right angle triangle. It can be used for any triangle. Let's do a little test. We take this. Are you game for a test, my dear? Alright? I know you young boy, young girl, you are just curious. How truthful is this formula? Alright? You just learned the sine rule and I want you to know it's right. So let's do a little test. You're given this information, 3, 4, 5. It's a right angle triangle. We have 53 degrees, this 36.9, this 53.1, alright, this 90 degrees. So we said, alright, we said sine 36.9 over facing 3 equal to sine 53.1 degree facing, look at it, facing 4 equal to sine 90 degrees over 5. Now please press your calculator. Is the answer accurate? I just want you to test it. Alright, what do you get? Sine 36.9 divided by 3. What do you get? Do you get the same as me? 0.200? Right, if you got it. Alright, let's put the 2 decimal place, alright? 0.200. That's the answer for this. What about the answer for this? We want to find out. Is it 0.200? Right? You press sine 53.1 close bracket divided by 4 and you will get 0.1999. Alright? I just want to show you that if I were to round up, would this become that? So we're about there. Alright, and I can just say rounding up, this will become 0.200. Now look at the sine 90 divided sine 90 divided by 5. Alright, you know sine 90, it is actually 1, but I just want to make sure you know it, and you divide by 5, you get a 0.2. Alright, and 0.200. So you say, hey, you are 0.2. They are all there. So you can be very convinced from this example. Sine rule is there to stay. I can even tweak it. Let's put sine over angle. Okay? Or I can say 5 over sine 90. Alright? I can say sine 53.1 over 53.1 over 4, and I can set sine, sorry, I was just a bit off. It's supposed to be this aside over the angle, right? I said 5 over sine 90, 3 over sine 36.9. Okay, you get 36.9. And I can say 4 over sine 53.1. Can you just please help me work it out? Do you get 5 for each one of them? Just test it and experiment. 5 divided by sine 90. Yeah, you get a 5. Do you see it? Alright, you put 3 divided by sine 36.9. 36.9. Do you get 5? I get 4.996. 4.996 is about 5. Right? And when you get 4 divided by sine 53.1. I get 5.001. It's all there. You know why the answer is not 100% accurate? Because these angles were also rounded. So that's why you don't get it at 100% of accuracy. But they all show you it is the truth that when you put an angle, sine of an angle over the opposite side, sine A over A, sine B over B, sine C over C, they are all equal. The ratio of the sine over the sides for the three angles of the triangle, irrespective of whether it's an obtuse, acute angle, or whatever triangle it is. Got your sine rule? Yay! Great!